Hello everyone, today we are going to have a look on the equations of velocity and acceleration in polar coordinate. However, we all are aware about their equation in Cartesian coordinate system. So let me first draw a Cartesian coordinate system whose two axes are represented as x-axis and y-axis, and let's consider a point P whose position vector from origin O is represented by r vector, and this r vector is making an angle theta with the positive x direction. So the direction of r cap will be like this and the direction of theta cap will be like this. Keep remember that theta cap is always perpendicular to the direction of position vector, right? So by using the symmetry we can see that this angle is theta. So I can write r cap in its basic components, that is, one will be in I direction and another one will be in j direction. So these two components will be cos theta I cap plus sin theta j cap. In the similar manner, I can write theta cap in its components like this will be sin theta, and since it is negative x direction, so I will consider minus sin theta. So its components will be minus sin theta I cap plus cos theta j cap, right? Now we are going to first write position of this particle in polar coordinate system, and you know that can be simply written as r vector equals r into r cap, where r is the magnitude which represents the length of this vector and r cap is representing the direction. You can verify it by putting the value of r cap like r multiplied by r cap is cos theta I cap plus sin theta j cap. And we know r cos theta and r sin theta in polar coordinates are equals to xi cap plus yj cap. So by putting the values of these two quantities, we reach to an expression which represent the position in Cartesian coordinate system. So now second thing which we are going to see is velocity. We know velocity can easily be calculated by taking the derivative of position vector with respect to time. So I can write v vector equals dr vector by dt, and this simply will be derivative of r dot r cap with respect to time. Now since r and r cap, because r will change with time and as a result r cap will also change, so both of them depends on time t. So I have to take the derivative of both these quantities, and I can obtain that derivative by simply applying the chain rule. So that comes out to be dr by dt r cap plus r into dr cap by dt, right? So dr by dt can be represented like r dot r cap. R dot represent dr by dt simply, plus r dr cap by dt I can calculate from here. Dr cap by dt will be just the differential of this, that will be cos theta I cap plus sin theta j cap. Differential of cos theta will be sin theta I cap plus cos theta j cap into d theta by dt. So it will be theta into theta dot, right? So I can replace that over here, so that will be theta dot theta cap. Now we have obtained the velocity expression in polar coordinate system. Here this first term represents the radial velocity, since it is dr by dt, so it is our radial velocity, and this second term theta dot represents the angular velocity. You must be sure about this. This represents the angular velocity, and if I look at this complete term, that is our theta dot, this represents the transverse velocity. Or the other name of transverse velocity is tangential velocity. Now we are going to have a look on acceleration in these polar coordinate system. So acceleration further can be calculated by taking the derivative of velocity with respect to time. So I will take the derivative of this whole term, that is d by dt derivative of the quantity r dot r cap plus r theta dot theta cap. So again we will be applying the chain rule over here, and I will obtain the r dot by dt, that will be r double dot r cap plus r dot d r cap by dt. Now apply the chain rule over the second term. Dr by dt will be r dot theta cap plus r d theta dot by dt will be theta double dot theta cap plus last term r theta dot d theta cap by dt. What d theta cap will be? D theta cap is minus cos theta I cap minus sin theta j cap, and cos theta I cap plus sin theta j cap is r vector, so it will simply be minus r cap theta dot, right? Now we will simplify this equation further. So we obtain r double dot r cap plus r dot dr cap by dt is theta dot theta cap, so it will be theta dot theta cap plus r dot theta cap plus r theta double dot theta cap minus r theta dot square r cap. Now taking r cap common out of these first and last term, we obtain r cap r double dot minus r theta dot square plus taking theta cap common out of these three terms, we obtain theta cap common, and r dot theta dot plus r dot theta dot, it will be 2 r dot theta dot plus r theta double dot. Now we have obtained 4 terms over here. This first term r double dot represents the radial acceleration. Radial acceleration due to the change in radial speed. This r theta dot square represents centripetal acceleration. And this term r theta double dot represent linear acceleration in tangential direction, linear acceleration, and this term 2r dot theta dot represent Coriolis acceleration. So that's all about velocity acceleration in polar coordinate. I hope you understand it. If you like the video, please do subscribe to my channel, and thank you for watching.